The prices in dollars for a particular model of digital camera with 6.0 megapixels and an optical 3 times zoom lens are shown below for 8 online retailers. Round sample statistics and final answers to one decimal place. Estimate the true mean price for this particular model with 98% confidence. Assume the variables are normally distributed. So we've got the different observations there, 187, 265, and so on up to 217. Those are the different prices. What we're being asked to do is estimate the true price of the mean with 98% confidence. So the first thing we're going to need to do is actually see what our sample statistics are for this data set of 8 observations. So we're going to go over to our calculator and do that first. So the way that we're going to go do that in our calculator is we're going to go ahead and in our graphing calculator use the stat function. And then we're going to go ahead and select edit because we're going to edit the first list and we're going to input this set of 8 observations in there. If you already have data in that list, you'll have to scroll up and clear the list, which I'll show you how to do. Once you've inputted your data, you're going to hit stat again. Then you're going to go over to calc, so the calculate menu, and you're going to select the first item, which is one variable statistics. You'll hit enter and then your stats will come up. So let's go ahead and see what we come up with. So with our 8 observations, we're going to go to stat. We're going to select item 1, which is edit. We're going to edit the first list. And if you have something here, you'll have to scroll up and you'll have to clear and then enter to clear your list. But in this case, we don't have anything here. So our observations are 187, enter, 265, enter, 222, enter, 197, enter, 195, enter, 181, enter, 250, enter, let's clear that, 217, enter. So now that we have them all in there, we're going to go back to stat. We're going to go to calculate, the calculate menu, and we're going to select item 1, which is 1 var stats, and we're going to hit enter. And we see that we have a mean of 214.25. If we round to the first decimal like the problem tells us, that's 214.3. And then our sample standard deviation is the 4th item that we see there, which is SX. Remember, the sample standard deviation has an S, it's denoted with an S. So if we round to the first decimal, that's 30.3. So as you saw in your calculator, the statistics that you're going to need are the mean for this set of 8, which is 214 and 30 cents. And we're rounding this to one decimal place because that's what we were told to do in the problem, right? So we were told to round sample statistics and final answers to one decimal place. And our sample standard deviation was 30.3, again rounded to one decimal place. So these are the statistics that we got from our sample. So since we have sample statistics, we're going to need to use the t-distribution. And what we're trying to do is we're trying to estimate the mean with 98% confidence. So if you'll remember, the formula for finding our t-value is t is equal to x bar minus mu over the standard error, and we use our sample standard deviation divided by the square root of the sample size. So x bar minus mu over s divided by square root of n. So we can use this formula and solve for mu, so we can use algebra to do that, and that helps us to solve for both sides of this 98% confidence interval. So our upper bound and our lower bound. So if we were to do that, we would end up with this formula here that helps us to find the confidence interval for a sample when our standard deviation is not known. We've already got our mean, or our x bar, and our sample standard deviation s. We know that n is 8 because we have 8 observations. The only thing that we're missing here is t. So there's a couple ways that we can go about finding t. You can use your t-tables or you can use your calculator. So in order to find t, we're going to need to know the degrees of freedom first. So remember that degrees of freedom for a t-distribution is equal to n minus 1. And so for us, n is equal to 8 because we have 8 observations. So if we subtract 1, that leaves us with degrees of freedom of 7. So if we go and use our t-table, then we're going to need to look for degrees of freedom of 7 and the confidence interval for 98 because that's what we're being asked for in the problem. So where that intersects, that's going to be the t-value that we're going to use. So let's go over to our t-table and see what that is. So this is what our student's t-table looks like. At the top, you see the confidence intervals that you're looking for. The second row, you've got the one-tail probabilities or alpha levels. And in the third row, you've got the two-tail probabilities or alpha levels. We're going to go ahead and zoom in on the area of the table that we need to look at. So we're just going to be looking at the top half here, and the problem is asking us for a 98% confidence interval. So we're going to be looking at this column, and then our degrees of freedom is 7. So we're going to be looking at this row, and where that column and row intersect, we get a t-value of 2.998. So that's going to be the t-value that we use in our problem. So as you saw from your t-table, the t-value is going to be equal to 2.998. I want to show you another way of calculating or arriving at that t-value without using your t-tables and just using your calculator. So if you go to second distribution or second vars and select the item number 4, which is inverse t-distribution, the first thing you'll enter is the probability, which in this case the probability is actually going to be 99% or 0.99, because if you think of what your normal distribution looks like and you're looking for the middle 98%, you've got 1% in each tail. So 1% in the left tail, 1% in the right tail. Since you're trying to arrive to the t-value on the right-hand side, that includes the middle 98% and it also includes the 1% on the tail on the left-hand side. So then our probability here for the t-value that we want is 0.99. Again, that's the 1% of the tail on the left-hand side and the middle, the 98% of your normal distribution, so or t-distribution, comma, and then you need to put in your degrees of freedom here, which for us was 7, because remember degrees of freedom is n minus 1, n is 8, so 8 minus 1 is 7, close the parenthesis, and that still gives you 2.998 if you round to the third decimal, which is what we got from the t-table. So now we have our x bar, we have t, we have s, and we have n. So we have everything we need to solve for our 98% confidence interval. So let's go ahead and plug everything in and see what we end up with. So we start the left-hand side of our equation as 214.3 minus our t-value of 2.998 multiplied by the standard deviation of 30.3 divided by our square root of our sample size, which is 8. And on the right-hand side, we have the same figures, just we're adding. So 214.3 plus 2.998 times our standard deviation of 30.3 divided by the square root of our sample size, which is n. And we close that parenthesis. So let's work on the left-hand side first. So 30.3 divided by the square root of 8 comes to 10.71. And on the right-hand side, the figures are going to be the same. The only thing that's different is that we're adding. So 214.3 plus 2.998 times 10.71. And then we'll multiply the 10.71 by 2.998, and we end up with 32.12. So on the left-hand side of our equation, we've got 214.3 minus 32.12, and on the right-hand side of the equation, we've got the same 214.3, but now we're adding 32.12. So on the left-hand side, we end up with 182.2 if we round to the first decimal, and on the right-hand side, we end up with 246.4, again, if we round to the first decimal. There's another way to calculate the 98% interval just using your calculator alone. So now let's go back over to the calculator and I'll show you how to do that. So in order to find the 98% confidence interval in your calculator, you would first go to Stat, you would go to Edit, and you would select item 1, which is Edit. You would input all of your data like we have here. You already have yours in here from the problem we just did, so there's nothing else to do. But you would have to go ahead and do this if you didn't already have it there. So now we'll go back to Stat. We'll go to the Test menu. And then if you look at item number 8, it says t-interval, and you might have to scroll down on your calculator to see this. But number 8 is t-interval, so we'll go ahead and select that. So when you select t-interval, it'll ask you if you want to input data or if you want to input stats. Right now we have data highlighted, So right now it's going to use the data in list 1. So you see there it says lists and it's got L1 there. List 1 only happens once, or the observations only happen once consecutively, so we'll leave that alone. We'll scroll down to C level, which is our confidence interval level, which for us is 98%. So we'll change this to 0.98. And then we'll go down to calculate and press enter. And we get a lower bound of 182.1 and an upper bound of 246.4, which is very similar to what we got when we did it by hand. There is a little bit of rounding error because by hand we had the z value that was rounded to 2.998, whereas this uses the data itself and doesn't round at all. Another way to do that, if you have the statistics and don't necessarily have the data, in this case you had the data. If you don't have the statistics, let's go back to stats and see how we would do that. So in the stats menu, you would select item number 8, which is t-interval. And then instead of data, you would select stats. And once you select stats, it then asks you for your mean, which we calculated our mean as 214.3, and maybe a problem on your exam will give you the mean as 214.3. So we'll go ahead and enter that. And then our sample standard deviation, we calculated it to be 30.3, but maybe that will be given to you in a problem. So then you could enter it here if you didn't have the data like we do in this one. N is our number of observations, which is 8. And then our confidence interval is already at 0.98. If it wasn't, we would go ahead and change it here. So now we'll go down to calculate and hit enter. And again, we end up with a lower bound of 182.2 and an upper bound of 246.4. And so this is actually what we end up with when we did it by hand. And this is because we rounded our statistics. So our sample mean was rounded here, and our sample standard deviation that we entered was also rounded here.